Hey guys, Michael from Kaku Chemistry. In today's video, we'll be going over some problems involving the ideal gas law. So we'll start with the ideal gas law, which each of these variables stand for, and then we'll work through two example problems that involve PV equals nRT. So the ideal gas law is PV equals nRT. P stands for the pressure, and that has to be in ATM. V is the volume and has to be in liters. N is the moles of the gas. R is the gas constant. That's the 0.08206. And the units are ATM, liters, moles, and Kelvin. And then T is the temperature, and it has to be in Kelvin. So you know you're going to be dealing with ideal gas law if the problem gives you if the problem mentions pressure, volume, moles, and temperature. And sometimes it might not mention moles, it might mention grams, so just know that you can take the grams and convert it to moles. So let's take a look at our first example. A sample of gas at 25 degrees Celsius, so instantly we recognize this is temperature, has a volume of 11 liters, so give you the volume, and exerts a pressure of 660 millimeters of mercury. And then we have the pressure. How many moles of gas are present in the example? Uh, Reading a problem, we see that we're dealing with N, T, V, and P, which means that this is the ideal gas law problem. So we'll just use PV equals nRT. In this problem, we're solving for the moles, so we're solving for N. We'll just isolate N, which will then be N equals PV divided by RT. We just divided RT to both sides. Then it's a matter of just making sure all these variables are in the correct units and then plugging it in. So let's start with P. Our pressure it's 660 millimeters of mercury, but it has to be an ATM. So the very first step is just convert that to millimeters into ATM. So we'll take 660 millimeters of mercury, and the way we convert mercury into ATM is just by multiplying by the conversion factor that in every 1 ATM there's 760 millimeters of mercury, so that way the millimeters of mercury cancels out. So we'll just do 760 divided by, or 660 divided by 760, and then that'll give us 0.868 ATM. If you're having trouble with pressure conversions, I'll link a video in the description where I go over how to convert between all the different units of pressure. So that's our P, it'll be 0.868 ATM. Volume, it's 11 liters. We want in liters and it's already in liters, so we'll just keep that as 11.0 liters divided by R, which is the gas constant, 0.08206. ATM times liters divided by moles times Kelvin, as you can see right here. And then T, temperature has to be in Kelvin, and it's in degrees Celsius. So we just have to add 273 to this to get into degrees Kelvin. So that'll be 298 degrees Kelvin. And then when we multiply everything together, the ATMs will cancel out, the liters will cancel out, and then the kelvins will cancel out. So we'll be left with moles. Then there'll be 0.868 times 11, divide that by 0.08206, multiply by 298. And then that will give you 0.39391 moles. If you're having trouble getting this number, just put a parentheses around these two numbers when you're entering into the calculator. So let's take a look at the next example. In this example, we have 1.09 grams of H2. As we talked about previously, when you have grams, you can convert this to moles, which is N. It is contained in a 2.00 liter container, so we have volume at this particular temperature. So we also have T, and then we're solving for P. So once again, because we're dealing with P, pressure, volume, temperature, and moles, we're going to be using the ideal gas law, PV equals nRT. Here we're solving for P, so we're going to isolate P. So P will equal nRT divided by V. I just divided both sides by volume. Then it's a matter of just plugging in the numbers and making sure they're in the correct units. N is the number of moles. We currently have 1.09 grams, so we have to convert this to moles, and the way to convert this to moles is by dividing by the molar mass essentially. So we multiply by 1 mole of H2 over the molar mass of H2, which is approximately 2.02 grams of H2, and that way the grams of H2 cancels out, and then you'll be left with the moles. So this will be 1.09 divided by 2.02, and that'll give us 0.53 540 moles of H2. And that's what we're going to plug in for N, 0.540. R is the gas constant, let me just write the units as well. So 0.540 moles. The gas constant is 0.08206 atm times liters divided by moles times Kelvin. And then temperature, that has to be in degrees Kelvin, but it's in degrees Celsius right now, so we'll just add 273 to this, and that'll be 293 degrees Kelvin. Divided by the volume. The volume is 2.0 liters, which matches the unit that we want. And then we can cross out the units. Moles will cancel out, liters will cancel out, and Kelvin will cancel out. When you're solving for the answer, you don't necessarily always have to write the units down like I am doing right here. But if you do so, then it'll ensure that you have all the correct units. Then we just plug this into the calculator. So 0.540 times 0.08206 multiplied by 293 divided by 2. Then we'll get that the pressure is 6.49 atm. And that's it. Those are some examples of how you would apply ideal gas law to a problem. So if you read a problem and you're dealing with pressure, volume, either moles or grams, or temperature, then you have to use the ideal gas law. So you just plug the numbers into this equation and make sure that the pressure is in atm, volumes in liters, moles is in moles, and then temperature is in Kelvin. If you want to learn how to ace chemistry, if you want to learn what's the best way to study for this class, if you want to learn some neat tricks and tips to take into your exam and do better on them, then you should head over to my website and get this free guide, 12 Secrets to Acing Chemistry. You can head over to www.conquerchemistry.com/chemsecrets. I'm going to include a link in the description below. Check it out. I think it's really going to help you, and you're gonna like it. Until next time, keep working hard and continue the good work.